Hi, I'm Mary, and this is another Magical Math Moment. This video is designed for Algebra 1 students being introduced to exponential functions for the first time. So a big question, especially in Florida on state assessments, has to do with identifying different types of functions given either an equation or a table or sometimes a graph. So we're gonna check that out and play the most ridiculous game, Is This Exponential? So just a quick review for you. We've already talked a lot about linear functions. The slope-intercept form of a line is y equals mx plus b, where m is the slope and b is the y-intercept. Hopefully you remember that all of the x values must increase by the same amount, and all of the y's are going to either increase or decrease at the same. So here, hopefully you see we are subtracting 2 each time from our y values. So when that happens, that's how you find your slope, right? So that's your change in y over the change in x. So the slope of this line is -2/1 or -2. So if you've got a table where you are adding or subtracting the same thing from y values, you have a linear function. With exponentials, it's a little bit different. Exponential form is y equals a times b to the x, where a is the y-intercept and b is the exponential rate of change. You'll be learning more about that when you get into graphing these, and that'll be a next video. So if you've got any kind of equation with an x up in the exponent, it is an exponential equation. When you look at a table of values for an exponential, you want to make sure that the x's are still going up by a consistent amount. It doesn't have to be 1. These could all be like 2's. That would be okay. Then you're going to look for the pattern between the y values. Now, if you try to add, you might say, oh, 3 plus 3 is 6. 6 plus 3 is 9, not 12. So we're not adding or subtracting this time. We're either multiplying or dividing. As you look at these differences, hopefully you see that we're multiplying by 2 each time. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. And finally, 24 times 2 is 48. So when you are multiplying or dividing by a constant, again, we're talking about y values, you have an exponential function. All right, linear functions, as you remember, are lines. Exponentials are going to kind of be curvy and a little weird looking. So let's take a look and try some of these. If I have the equation y equals 3 to the x, I have an x up in the exponent. So yes, this is exponential. Y equals 7x minus 4. Hopefully you notice that this is linear. There are no exponents that we see. Now we can get in here and argue that the exponent is 1, but we're not going to get that wild here, okay? So since there is no x up in an exponent, no, this is not exponential. And finally, if you have y equals 2x to the third, I do have an exponent, but there's a number up there. It's not an x, so this one is also not exponential. Okay, now let's go to the tables. So I'm looking at the x values, and they're all going up by 1, so that's good. I'm trying to see the change here, and I see it's decreasing. It's getting smaller. So instead of multiplying by something, I'm probably dividing by something. And if I'm not sure what to do, I can always take the term on the right and divide it by the previous term to figure out really what I'm multiplying by. I know that sounds really weird. So if I look at 27 divided by 81, I get a third. So really I'm multiplying by a third. Now you may argue that this is the same thing as dividing by 3. But when we're talking about exponential functions, we're really looking for a multiplicative constant. So when you get to graphing, keep that in mind. For our purposes here, if we're dividing by 3, that's the same as multiplying by the reciprocal 1/3. 1/3 of 81 is 27. 1/3 of 27 is 9. So that's really all we're doing here. Or we're dividing 81 by 3 to get 27. 27 divided by 3 is 9. In either case, this is an exponential function. In the next table, my x values are increasing by 1. And then when I look over here, it looks like they are getting larger, and it looks like it's a constant amount. To get from 2 to 8, I know that I'm adding 6. And then the same thing here, -4 plus 6 is +2. So this one is not exponential. It's actually linear, and it's got a slope of 6. All right, let's check out the graphs. So here we are. In the first one, this is a line. This is not exponential. It's linear. This one is an example of an exponential growth. It's going up, up, up. So that is exponential. This graph is a line. It's not exponential. This graph is essentially an exponential that's been reflected over the x-axis. So as you can see, it's approaching the x-axis here. That's going all the way down toward -infinity there. This one is also exponential. This is a horizontal line, which is a function. It's a linear function. It's not exponential. I hope that this video has been helpful for you in determining whether some given information expresses an exponential function or not. Thank you so much for watching. Please like, share, and subscribe, and I'll see you next time. Bye.